It's the same problem, the previous one, the just restating the problem here. So the graph, the curve y is equal to x square, straight line x is equal to 2 and y axis, these three enclose this area, the shaded one, and the enclosed area is revolved around y-axis, and we need to find the volume. In the previous video we found the volume using cylindrical shell method, because if we take small section here and if this one is revolved around y-axis, we get something like cylindrical shape. So we can say it's like that. So we will have, so basically we will this is probably not very good drawing. So basically cylindrical shell, and this will have a thickness of dx. The cylindrical shell thickness is dx and the height is fx, and of course the radius is x. That's what it was in the previous problem. And this, since it's like a washer cylindrical shell, so it has, each of the sections will have a did have a hole inside. So the volume we calculated in the previous video, but this time we want to find the same volume using disk method. So let's do it that way. So what we can do, if we can appreciate that, first we find the volume of revolution of the straight line x is equal to 2 about y-axis. If we do that, we can see that only the straight line is revolving around y-axis. And what's the volume generated? We can see that if we do here like that, it's a small section. Actually we don't need to do that because this is a solid, the shape that will be a cylinder, obvious cylinder, a solid cylinder with, if we take small sections we can call it a disk. So this is how we do disk method problem. So we have pi r square h, basically the volume of the cylinder. So this is 2 4, this point. So the height, so of course the straight line up to here, not because the straight line goes for infinity, so straight line up to y is equal to 4, the straight line x is equal to 2 up to y is equal to 4 is revolved around y axis. So that's what we are trying to find, that's the volume we want to find. So r will be sorry here, so r is, if we look here, r is 2 square and height is 4, so this is 16 pi cubic unit. So that's the volume there. And now if we find the same, the volume generated by revolving this parabola only about y-axis, so now we can use disk method. If we take a small section here, maybe I can use a different color, small section here, this is dx, the thickness, and this one is x. So pi x square will be the cross section of one of the circular disc, and each of the disc will have a thickness of dx, dy it will be, sorry, so dy, and we will have to, so there will be, again it's disk method, it's looking like disk, like a disk, each of the sections, and it's a solid circular disc. So the area, surface area of the disc is pi x square times dy is the volume, volume of the disc. So we have to integrate from 0 to 4 to get the full volume. So here it's becoming pi outside and x square, this is y, so pi y square over 2, 4 and 0, so this is becoming 8 pi. So now if we look at two of the volumes, or yeah, let's call two of the areas, not volumes, so look to two of the areas. First, the area is, this area is, if we call it A1, and the corresponding volume is V1, the area that is that is enclosed by the straight line x is equal to 2 up to y is equal to 4. This is a full this area, which is, I don't know, uh, maybe I can draw like that, this full area, and the area that is enclosed by just the parabola is this much, which is A2, and corresponding volume is V2. So if the desired area is basically the remaining one here, so if we subtract A1 A2 from A1, which will be corresponding volume will be V1 minus V2, V1 minus V2, we will actually get the volume that is generated by these enclosed areas. So which enclosed? This one, which is our interest, this one, which is enclosed by the parabola, the straight line, and x-axis. So these three. So the total volume minus this volume is this volume basically. So if we do that, we will get V1 is 16 pi minus 8 pi, which is 8 pi. This is as same as before. In the previous video we got the same result, but this time we used disk method. So we had to subtract. So we used only one line and considered that when it's revolved around y-axis we get a volume, and then we consider this line and we subtract the second from the first one to get this volume basically. So yeah, so as we can see, the same problem, it could be done using shell method. That would be just one volume pure, just one calculation, but here we had to subtract, but we used disk method. So depending on the problem, depending on the function, we should see which problem suits better. Sometimes it will be just disk method we have to use, sometimes it will be just shell method we have to use, but sometimes we can choose. So yeah.